it's part of the unit circle. Hopefully you got your unit circle attached and you know how that done. If not, if you have this book at home, you open from the back, okay, and you open in a page, all right, and then right there on that page is your unit circle, okay? So it's with the coordinates. We're going to transition to coordinates. You can still use the triangles. Typically, in a typical year, what I do is I give you a test on Trig up to the point of us learning the triangles on the unit circle. I make sure you understand that. And then we move on to the coordinates. This year, you're getting the option of using both. When it comes time for calculus, I tend to stick to the coordinates because we just do radian measure everywhere. We don't do any degrees. So most of what we're going to see from here on is probably going to be radian. Okay. All right. Let's do this. So we're only going to do the first 6 examples today. And then I'm going to work with a small group again for getting some more help, the next like 4 problems on the test to hopefully help you out on that. So those of us that need to retest are going to retest on Friday. Okay. All right. So our unit circle is literally a circle that is 1 unit. And let me talk. I was going to play with Desmos for just a minute. Okay. Oh, there's a Desmos right there. Oh, not that one. But that looks cool, doesn't it? That's my other class. All right. Oh, I'm just going to type in Desmos. Okay. So one thing you probably missed in geometry last year, okay, was the equation of a circle. All right. It's typically a geometry thing. They usually don't get to it very early on. So I'm going to guess that you missed it. So it's x squared plus y squared equals the radius squared. Let's say our radius length is 2. So I'm going to square the 2. I get 4. If you notice on here, I'm out 1, out 2. So you can count that the radius is actually 2 and not 4. I could change this number for the radius and the radius gets bigger. I could make it a 25. My radius gets even bigger. Okay. Just like with our other graphs, we can transform a circle around the plane, and you don't need to write any of this down. So I could move its center. So that if I put it with the x, it's going to move in the x direction. And if I put it with the y, it's going to move in the y direction. Okay. Again, this is just this is background you should kind of have, but as long as you just understand that is an equation of a circle. Literally what we are doing here is a unit circle is a circle with unit 1. Okay. And look, it's very Pythagorean looking too, kind of has that element to it. Okay. So that is our unit circle is x squared plus y squared equals 1. That's its equation. So x squared plus y squared equals 1. Okay, and you'll notice in this picture here, the radii are all out 1 unit. Whether it's a positive unit or a negative unit, they are all out unit 1. Okay. Each value of the unit circle corresponds to a set of coordinates, x comma y. And we did talk about this before break, that x comma y actually is the cosine comma the sine. So on this picture, there's coordinates, and they correspond to an x comma y. And I know my picture's kind of squished and blurry. I probably should fix that. Now, for the most part, we are going to focus on values that are on our standard unit circle. Okay. In these, the values don't have to be. Okay. So the first couple we're going to do, we're just going to use some coordinates that they've given to us. Okay. And find all 6 values of the trig function of the angle of theta. Okay. So I've got to find all 6. So I'm going to start with my sine of theta. Notice the coordinate is right there. I know it's kind of small. Let's see if I can blow it up a little bit. So remember that the cosine is the x value, the sine is the y value. And that's something we kind of touched on a little bit before. Now we're really going to bring that into play. So my y value of this coordinate is 3/5. Okay. My x value of this coordinate is -4/5. All right. And then before break, we learned that there's a little bit of a trig identity that we've been using. So the tangent of theta is the same as saying the sine divided by the cosine. And we kind of went into that. What do you mean?
Nothing.
Okay. Don't annoy your mother. All right. Tangent. Actually, I'm going to write my tangent up here. Okay. So the tangent of theta, my sine is 3/5, and the cosine is -4/5. We don't like complex fractions like that. Okay. So we would tend to flip and multiply that. So our 5's cancel, and we get the tangent is 3/-4, or you can float the negative out in front. Okay. Let's talk about a shortcut, as I know you all are about the shortcuts, right? It's one thing that I know I need a lot of steps, okay? And I want to see clearly your work, right? This is tedious, repetitive, and unnecessary here, okay? So this shortcut, completely acceptable. When we flip that reciprocal, aren't we? And it just meant that, hey, these guys were the same. Doesn't matter if I flip it, aren't they going to cancel? Can't I cancel them right there? We know that that's going to happen every time we flip, as long as the denominators are the same. Okay. Hopefully that's a good shortcut. So it would save us that whole line of work right there. Okay. So if if the denominators are the same in a complex fraction, you can just cancel the denominators. Okay. Hopefully that's a handy one. All right. Now we've got to talk about the reciprocal identities, right? So we need to talk about the cosecant of theta. So what would the cosecant of theta be? Can you guys tell me in the chat? What do you think the cosecant of theta is? Nobody knows? Or are we just delayed right now?
Miss Ballard, can you repeat the question?
What is the cosecant of theta?
Oh, okay.
All right. I'm seeing a couple of different things. Okay. So let's review our reciprocal identities, because I'm seeing a few people have got it, and then some people are a little bit mixed up. Okay. So if I'm looking at the reciprocal identities, remember that cosecant is the reciprocal of sine. Okay. Secant is the reciprocal of cosine. And then cotangent is the reciprocal of tangent. Okay. Literally all I'm going to do is take the one I've got and flip it. Okay. So cosecant would be 5/3. Okay. Help me out. Let's try to redeem ourselves. What would secant be? Tell me what secant would be in the chat. I need to hear from everybody. I want to make sure we're all understanding. On this one, it does not matter where you put your negative. Okay, I've got about 4 of us. Who else? There we go. Okay, so I'm going to just flip my negative in front, 5/4. Okay, so my cotangent, when I flip this one, it would be -4/3. I'll leave that there for a couple seconds to make sure you got it. Okay, let's take a look at example 2. So example 2 is more of the same. Okay, I'm going to ask for a little bit more help this time. Okay. All right, so we're going to do our sine, our cosine, and our tangent to start. Okay. So here is our point right here. What is the sign of that coordinate? Can you tell me in the chat? So what's the sign of that coordinate? Really, I'm going to zoom in more because I want to make sure you don't. Look on your paper. I know it's a little fuzzy, but want to make sure you get it. What's the sign of that coordinate? Remember, the first thing you got to think to yourself is which coordinate, which is the x the sign or the y the sign? My hint is to think alphabetically. want to make sure we're all getting it and paying attention. I still see a bunch of people not helping me yet. All right, I'm liking what I'm seeing. Okay, and you got to watch the signs. I saw one or two miss the negative. Okay, so we've got negative 12 over 13. Which identity is the reciprocal of sine? So which one is the reciprocal of sine? What did we just say a few minutes ago? So which one is the reciprocal of sine? I'm looking for, there we go. You guys answered it right. Okay. So there's nothing wrong with flipping that right now. Okay. So I could just go, they don't tell us what order we have to do these in. I always start with sine, that's just my habit. Okay. I could have started with any of the ones that are there. Okay. All right. Help me out. What's the cosine? Tell me what the cosine is. All right, it's looking good. We got negative 5 over 13. Okay, what's the reciprocal of cosine? So which identity is the reciprocal of cosine? All right, we're looking good. Looks like the dust is getting kicked off. The secant of theta equals negative 13 over 5. Perfect. Okay. The next one we got to do is tangent. So remember, the tangent is the sine divided by the cosine. So I'm going to take my negative 12 over 13. I'm going to divide by my negative 5 over 13. All right, what was the cool, awesome shortcut that we learned right here? So what can I do? What can I do? Okay, we were paying attention, so that's good. I like it. Let's take the shortcut. The other thing I can do is a negative divided by a negative is going to go positive, right? So this is going to be 12 over 5. All right, so cotangent of theta. Can you guys tell me in the chat, what would the cotangent be? All right, good work, 5 over 12. So here's another thing I want to point out, because I want to keep emphasizing this. I know that we were having trouble yesterday with the orange circle and the signs, okay? That still comes into play. You still need to understand that concept, even though we're back and we're in this coordinate world where it kind of works out for us. Because you always want to be able to double check your answer, and one way is to just at least spot check the signs. So this is in quadrant 3. In quadrant 3, we know the only thing allowed to be positive is tangent. Notice that tangent and its reciprocal are positive, and that everything else turned out negative. Okay, that's the way it should be. If I didn't have that, then I don't know something was wrong. If I'm doing all 6 identities, and either they're not all positive, only 2 of them should be positive. Okay, every time. All the rest of them should be negative. Okay. All right. This is going to be like the hardest question on the test on example 3, 4, and 5. Are you ready? Do you hear the sarcasm? Okay, here we go. So it wants me to find the point on the unit circle that corresponds to the real number t. Okay, so I'm going to get out my coordinates unit circle. I'm going to find 2/3. Okay, this is tough. I am going to pick that coordinate right there. So all I have to do is write that coordinate down. So the coordinate on this one is negative 1/2 square root of 3 over 2. Now, for our tests in here, obviously, whether you test in the classroom or you test at home, you're going to have your unit circle available to you, okay? When we get closer into calculus, and if we've got some time at the end, we'll work on some memorization techniques, because you won't be, I mean, you can still use it on your homework next year, but you won't be able to use it on next year's tests, okay? All right, that was a tough one, wasn't it? Right? That was rough. So rough that we don't want any of those on the test, right? None of those on the test this time? Or do you think you could handle one of those on the test? I like that Amy's smiling at me, so I've at least made somebody smile. I hope I'm envisioning that all your avatars are smiling right now. So, all right, even the ones that are scowling, I think, are smiling at me right now. All right, it was difficult, yes, okay. All right, good. All right, let's look at number or negative or 4. That one's not quite on our unit circle, okay? It's there, actually. It's just we have to find it. So do you guys remember when we talked about coterminal angles? Okay. And I want you to remember, we moved into radian mode. So when we did all the way around the circle in degree mode, remember we added 360. When we do all around the circle in radian mode, what do we have to add and subtract? Can you guys help me out with that? What do I have to add and subtract? Andy, did you finish your must-dos? You've only got like 15 minutes, dude. All right. I've got a couple people saying 2 pi. All right, so, and I'm going to show you, I'm going to talk about 2 ways to do this. So we could add 2 pi to this and get what was on the actual unit circle that we have, right? So remember in over 4 world, instead of adding 2 pi, we add 8 pi over 4. So this would be the same as saying 7 pi over 4, which we can see that right here, okay? All right, or remember how we counted the wedges? So if I went from here and I counted back 1 pi over 4, we would also get to the same set of coordinates. It's up to you how you do it. It doesn't matter to me, okay? All right, you got to find the one that works for you. So all I'm going to do is write down this coordinate. We got to be careful because there's a negative hiding in there. Square root of 2 over 2, negative square root of 2 over 2. Okay, you have like 30 seconds right now. You probably don't need it, okay? You probably need like 5 seconds. Write down the coordinate for 5 pi over 6. Put it on your paper. We're not typing it in. Just put it on your paper. Okay, let's check it. So 5 pi over 6, I found it right here. So we would write down negative square root of 3 over 2, 1/2. Okay, that's all there is to it. Okay, there's going to be some of those on the homework tonight. And again, that's a baby step, right? Are they really going to ask us that in calculus? Probably not. Okay, they're going to ask it. We're going to have to solve like we're going to solve in the next example. All right, but it was getting you the idea of you have to recognize where those points are and that they're points. Okay. All right, so now we're going to use the unit circle to actually evaluate like we were evaluating with our triangles. Okay, so what I'm doing right now, we've already done this with triangles. Okay, we're just going to use our coordinates to do this. So the sine of pi over 6, we want the cosine of pi over 6 and the tangent of pi over 6. And because that's what they asked us to do here. We could very easily get the other 3. Okay, that's a total possibility here. Okay. All right. So I'm going to go look for pi over 6 on my unit circle. I'm going to zoom out just a bit. Here's my pi over 6. So is the sign, help me on the chat, is the sign the x coordinate or the y coordinate? I want to hear from everybody. I want to make sure you're understanding this. Okay, so we all understand that it is the y coordinate. So I would just take this value of the y coordinate, the sine of pi over 6 is 1/2. Just as if I had my 30-degree triangle and I looked at the opposite over the hypotenuse. Okay, this is another way to do it. Okay, the cosine of pi over 6 would be my x coordinate. So I'm just going to write down the x coordinate. So it'd be square root of 3 over 2. All right, I want to make sure we understand this piece. How do I get the tangent based on the sine and the cosine? So what do I have to do to get tangent? And I want to know the trig piece, not the numbers. Okay, are you guys sure about that? Well, I've got one person that's saying sine over cosine. A lot of people are thinking cosine over sine. Scroll out or flip out a couple pages in your notes and see if you can find it. Revise your answer if necessary. Okay, I like that Matthew put the little star to, like he did a typo. That makes me smile. Okay, so it's got to be the sine divided by the cosine, right? So I'm going to take my sine 1/2 over square root of 3 over 2. We're going to use our new favorite shortcut, right? And just cancel those denominators. So now I have 1 over square root of 3. But guess what? I cannot leave it like that, okay? Why is it sine over cosine, Nitzel? Is that what you're asking? Yeah, because that's just the trig identity. It's a memorized thing. We wrote it down probably in the last lesson. Let's look. It was probably in this one here. Nope, it wasn't in that one there. Was it in the one that it was? No, I went too far. It was in the 9-3. We wrote it. It's right here. Okay. So, and those ones, reciprocals kind of make sense to us. The quotient ones, you just have to remember. Okay. All right. And you're going to use that sine over cosine one all the time. So you just got to know it. All right. So we are not allowed to leave that radical in the denominator, right? So we don't like to see it. So we're going to rationalize it. And here's another shortcut for us. Okay. I don't want to see square root of 9 on anybody's paper. Okay. Let's not do that. You're in advanced math right now. Let's not do that. The little arithmetic, let's leave that off. Okay. So across the top, I get square root of 3. Across the bottom, I would get square root of 3 times square root of 3, which is the square root of 9. What should I be writing instead of the square root of 9? Put that in the chat for me. What should I really write when I see this? Yeah. So when you have a radical times itself, it's the number underneath. Okay. Now, be very careful from here. That's the answer. At some point, you're probably going to realize that 1 over square root of 3 is always going to be square root of 3 over 3. And that 1 over square root of 2 is always going to be square root of 2 over 2. Okay. What you can't do, so don't write this down. What you cannot do is this, because one's inside the radical and one's outside. In order to cancel something on the top and the bottom, they have to be an equivalent number. Square root of 3 is like 1 point something. It's not equal to 3. So I cannot cancel that. Okay. I could, however, if it was like this, if it turned out like this, then I can cancel the 3's. Hopefully that makes sense. Okay. Only if they're both inside or both outside am I allowed to do that canceling. Okay. So this was our okay way to do it. All right. That's where I'm going to stop today. All right. That should get you enough to do the homework. We will continue this one tomorrow. We're not going anywhere yet, though, because first of all, we have the joke of the day. We missed out on the joke of the day yesterday. And then I'm going to work with anybody who, work with a group of people who need some more help getting ready for the test on Friday. Okay. So let's do the joke. It's a really good one.